Hey guys, it's Kerry, and in this video we're going to look at Boolean values and conditional statements. So I'm going to get started in terminal. I'm going to clear out everything I had before, and I'm going to enter the Python 3 interpreter. So first off, when it comes to Boolean statements, we talked about this a bit in class. Boolean statements are named after the mathematician John Boole, and they all have to do with logical comparisons. So an example of a Boolean comparison that's pretty simple would be 13 is greater than 8. And this returns the first possible Boolean value, which is true. If we try something different, like 13 is greater than 15, it returns the other Boolean value, false. So the only two possible Boolean values are true and false. I'll just put a note over here. So the same way that there were infinitely many integers or infinitely many combinations of strings that you could make, in Boolean values there are only true and false. So we know how to do greater than comparisons. Less than comparisons work how you would expect. So 13 is less than 15 returns true. If we try something like 13 is greater than 13, that gives us false because 13 is not greater than 13. So if we want to do a greater than or equal comparison, then we say 13 is greater than or equal to 13, and that returns true. We could do 15 is greater than or equal to 13, and that will also return true. But if we do something like 13 is greater than or equal to 19, that returns false, like you'd expect. So this kind of raises the question of how do we compare two things to see if they're actually just equal? So if we wanted to check that, we could do 13 equals 13. Well, let's see what happens when we test this. So 13 equals 13 has an error. It says it can't assign to literal. And what that means is the equals operator, when it's just one equal sign, isn't actually a comparison operator. We've used this operator before. This is the assignment operator. So what it's trying to do here is it's trying to assign the value 13 to the value 13. And you're not allowed to use 13 as a variable name, so it doesn't let you. But the bigger problem is that this equal sign, when you just have one equal sign, it's not about comparing to check if these things are equal. It's about setting them equal to each other. So if I want to compare these two values, instead of using one equal sign, we'll have to use two equal signs. 13 is equal to 13. And what that does is this version of equals is a comparison. It checks to see are these two things actually equal, whereas the singles equal sign tries to assign the value like we've used it before. So I'll press enter. So 13 equals 13 is true. All right, so let me quit out of this terminal. Let me clear it one more time. And let me jump back into it just so that we have a little bit more room to work. So I think this gets really interesting when we start to talk about variables. So let's see, let's use our classic example. We'll have a variable called age equals 31. Notice I'm using one equal sign because I'm not trying to compare age to 31. I'm trying to set age, I'm trying to assign 31 to age. So now if we do print age is 31. So the same way we did all these comparisons before, we could do all these comparisons. Age is greater than 25, and it will use the 31 value in the comparison. If we want to do something like age, let's check if age is equal to 60. And we had to use two equal sign that time because instead of trying to reassign age, we're trying to compare is the value of age, 31, equivalent to 60. So one equal sign assigns meaning, two equal signs compares to see if they're actually equal. Let's try age is equal to 31, and that returns true, as you might expect. However, if we try something like age equals 50, this is no longer a comparison. We are actually reassigning age to represent the number 50. And so now if we do that, and we print out the age, it will just give us 50, because you reassigned it using the singles equal sign. All right, so you might be wondering, how does this stuff come up in a Python program? So we've got this file open in Sublime Text, file1.py, and let's see. Let's make a password checker bot. So I'm just going to make a quick comment to myself. The correct password is open sesame. So now what we'll do is, in order to run this program, we'll have to ask the user for a password. So I'm going to say user password is equal to input what is your password space. And now this will ask the user for what their password is. It will store that end user password. Let's say that we have some protected data and we only want to let them know if they have the right secret password. What we can do is we actually have to have two different possible courses of action here. If they give us the right password, we have to do one thing. If they give us the wrong password, we have to do something else. In programming, these things are called conditional statements. So these are really closely tied to Boolean values because what we're going to be doing is we're going to be checking to see if something is true and then doing one thing, or if something is false and then doing something else. So let's try this one out. If the user password is equal, because I want to compare it to Open Sesame, dot dot, and Python will start me off with an indented block here. And what that means is if this condition is true, everything that's indented will actually happen. So I'm going to do a couple of things. I'm going to print that is the right password. And then I'm going to print welcome to the secret web page. And because both of these lines are indented, these lines will only run if this condition is true. So what we're going to do next is every time you have an if statement, you're also able to say what to do if something else happens. So if something else happens, what we'll want to do is a whole different course of actions. For else, you don't need a condition. It will always run the else code if the original condition is not satisfied. So let's say they type in something else like swordfish or something. That's going to be the wrong password. And so these two lines of code won't run, but it does fall into the else category. So let's print out that is the wrong password. And then print blocking you out of the secret page. And then let's see, maybe at the very end of this, let's print out, regardless of what happens, let's print out thank you for trying the app. So what's going to happen is, well, we should just run the program to see what happens. So let's do Python 3, drag the file over, run the code. So it says, what is your password? So let's try it with the correct password the first time. So Open Sesame. So what's going to happen is when I type enter here, it's going to store Open Sesame in user password. Then it's going to check to see if the user password, the thing they entered, is equivalent to Open Sesame. And in this case, it is. So what happens is it runs, this is the right password, welcome to the secret web page, the two indented lines of code. Because the if condition was satisfied, it actually skips running the else condition. That only runs if they get the wrong password. And then it will print out this last line of code because it's not indented, which means it should run no matter what. So for us to fully test our code, we actually should test what happens if we put the wrong password. So let's rerun the same code. What is your password? Swordfish. Press enter. That is the wrong password. Blocking out of the secret page. Thank you for trying the app. So it looks like this time it ran the else code because the condition, the user password, was not equivalent to Open Sesame. And then just like last time, when it was done printing out the else block, it actually prints out this last line of code. Thank you for trying the app, because that line of code is not indented, so it runs regardless of whether the condition is met or not. There's a lot of places you can go with this app. I hear my dog barking in the background, so I'm going to call it good evening.